Good afternoon,
done
sir.
that. Good afternoon. Good afternoon. So we have done the learning module. Uh, so we have seen some of the learning models in the last couple of classes: decision tree, naive-Bayes classifier, genetic algorithm, artificial neural network. Now today, my plan is to discuss another topic, which is required to do the inference but in a uncertain domain. Now I hope you remember that we have seen various inference mechanisms, inference algorithms like resolution, unification in the certain domain, and we have seen Bayesian network algorithm in the uncertain domain. And in that class, if you remember, I told you that there is another model, there is another method is there to infer something in an uncertain domain. Okay, and that is called fuzzy logic. Okay, so today I will discuss and again the very introductory part of the fuzzy logic, that how you can infer in a fuzzy domain, right? But before going to that, you should know how a fuzzy logic is dealing with, right? And how fuzzy logic is different from the Boolean logic, the classical logic that you are familiar with, right? Okay, so let me okay, I hope the slides are visible. Okay, so now these are the points that I want to cover, but I don't know that whether all these things will be covered, can be covered or not in a single class or 2-period class. But I will try to cover as far as possible, right? Now let's start. Okay, so before starting, what is the basic idea of Boolean logic? Can anyone tell me what is the fundamental concept of classical logic? Can I get answers from anyone? What happens? Boolean logic. Boolean logic. What is the meaning of Boolean logic? Okay, so Aditi answers that there can be only two possibilities. Okay.
স্যার বলছি আবার রিপিট করবেন স্যার পার্টটা, আমার একটু নেট কানেকশন আটটা আনস্টেবল স্যার, একটু প্রবলেম হচ্ছে।
Boolean logic. Boolean logic, you are quite familiar with Boolean logic, right?
Yes sir.
Okay. Boolean logic means what? What is the meaning?
0 আর 1 দিয়ে সব ডিলিং হয় ওটাই।
Okay, fine. So everything is in terms of 0 and 1. Everything in terms of either yes or no, right? Everything in terms of either black and white. Fine. But the way human mind is working, human mind does not always possible to deal with in this 0 and 1 kind of fashion. Okay. As for example, suppose I am giving you one statement, say one condition, like this, that if the annual income, try to listen very carefully, right? If the annual income of a family is greater than 60K, then the family is said to be rich, right? Got my point? What I am saying is a condition. I am giving a statement that if the annual income of a family is greater than 60K, then the family is said to be rich, right? Now, if it is a classical logic, if it is a Boolean logic, then if the income of a family is 59.9K, can it be there in the rich family category?
No, sir.
No. Very good. But if it is 60.5K, then it will be in the rich family category, right?
Yes, sir.
Very good. But the point that I am trying to say over here, that as a human mind, can we precisely think in terms of this? Can we differentiate between 59.9 and 60K? Can we really differentiate? No. Right. But if you are following the Boolean logic, you have to deal with in that way, right? So what I am trying to say, listen very carefully, that it is not always possible for a human to use in this type of precision, right? Because our mind works in an imprecise way. There may be some approximation, there may be some vagueness, okay, and you have to deal with that. Whatever we are talking about in Boolean logic, that is the ideal scenario, but that scenario is not always appropriate as far as real world is concerned. Real world does not follow every time in this classical way. So that's why, so to consider that approximation, to consider that vagueness, another type of logic comes into play, that is called the fuzzy logic. Okay, so fuzzy logic, what the first statement says, the first point says, is not the logic that is fuzzy, but the logic that is used to describe the fuzziness. So to represent the fuzziness which is there in our real world, or always there, fuzzy মানে vague, fuzziness মানে হচ্ছে approximation, right? আমরা যে বলি না অনেক সময়, is a very common term that it is fuzzy, means what it means. It means that it is not clearly defined, it is not determined properly, right? Like, as for example, I am giving here some terms which we regularly used in our real life. So these terms are always with a fuzzy terms, right? Although we are using, right, like very tall, large profit, height pressure, tall man, moderate temperature.
Yes,
all
sir.
these terms are actually the fuzzy term. Why?
Yes,
If
sir.
you ask me why, the reason is, when you are saying a profit is a large, maybe if I am, if it is to me,
স্যার অ্যাকুরেট না, প্রফিটটা মানে অ্যাপ্রক্সিমেটলি, মানে কতটা লার্জ সেটা কিছু না।
বলছি শোনো, it may be, suppose I am earning a profit of 10K, it may not be large to me, but to you maybe it's large, right? So that's why you can't say very assuredly that this is there in the set. Okay, so a 10K profit can be there in the large category, cannot be there in the large category, or it may in the large category as well as it may in the very large category also, but you should distinguish these two. Okay, So what I'm trying to say, so fuzzy logic, what is the meaning? The fuzzy logic is actually what the next point says, that it is based on the idea that all things admit of degrees. Okay, so that is called the membership degree. So a profit of 10K can be there in the large category with some membership degree, right? Similarly, a height of a person, it can be in a tall category, it can be in the very tall category, okay, but with a different membership degree. Now in classical logic, in Boolean logic, they are also the membership degree, but that degree is either 0 and 1. But in case of fuzzy logic, this membership degree can be any value in the closed interval 0 and 1. Okay, so that's why in another term I can say that fuzzy logic is a multi-valued logic, whereas Boolean logic is a two-valued logic. So in a Boolean logic, it is either 0 or 1. But here in a fuzzy logic, the value can be lied between in the closed interval 0 and 1. Right? Now another way I just go forward a little bit and then I will come back. Now to understand the
স্যার আপনি যেটা বললেন যে আমার কাছে যেটা লার্জ হচ্ছে সেটা আপনার কাছে লার্জ না হতে পারে, তো সেটাই কি ফাজি লজিকের এক্সাম্পল?
হ্যাঁ, মানে আমার কাছে যেটা ধরো লার্জ, সেটা হয়তো তোমার কাছে ভেরি লার্জ, সেটাও হতে পারে। ঠিক আছে, মানে ধরো 10K প্রফিট আমার কাছে হচ্ছে লার্জ, সো লার্জ মিনস বেসিক্যালি ইজ আ সেট, লার্জ সেট। তাহলে 10K this profit belong to this large set with some membership degree. Abar in another way, that 10K profit is belong to the very large set in another membership with another membership degree.
Yes, sir.
Okay, now see, I hope with this picture, this diagram, you can get a clear picture about the difference between the Boolean logic and multi-valued logic. What I'm trying to say, now see here, the Boolean logic, after this point they are short bound. Okay, so in a Boolean logic, basically there is sharp boundary between not belong to the set and belong to the set. So this part is not belong to the set, this part is belong to the set, right? So there is a sharp boundary. So basically it's a clear black and white picture, black and white kind of thing. But in a multi-valued logic, you see there is a smooth boundary, there is a smooth change between not belong to the set to belong to the set. Okay, and see, the values are ranging from 0 to 1 in a closed interval. So there can be, so these values are actually called the degree of membership. Okay, so here maybe this set is not belong to the set completely, but those elements are not belong to the set, but starting from this, all the elements are belong to the set but with a different membership degree, and as soon as it becomes 1, then means it completely belong to the set. Are you getting the point what I'm trying to say so far?
স্যার একটু বুঝতে পারছি না, আরেকবার একটু রিপিট করুন প্লিজ।
বুঝবে, আস্তে আস্তে বুঝবে, আমি আরো এক্সাম্পল দেব। I hope it will be clear, right? Okay, now I am going back. Okay, so the second point, the second point says what? That fuzzy set theory resembles human reasoning in its use of approximate information and uncertainty to generate decisions. Okay, so it is actually used. Why it comes into play? Why it is introduced? It's introduced to resemble the human reasoning. Now, human reasoning is always there, the approximation, because I mentioned, if you remember, when I discussed about that Bayesian network, I told you that in a real world that is a full of uncertainty. So whenever you are doing the reasoning, that reasoning should also need to represent that uncertainty, right? So here the fuzzy logic is another model to represent that uncertainty. Okay. Now, what is written at the last point? Boolean logic uses the sharp distinctions, right? That the picture that I have shown you just before. It forces us to draw lines between members of a class and not members of a class. For instance, we may say that Tom is tall because his height is 181 centimeter. If we draw a line at 180 centimeter, we would find that David, who is 179 centimeter, is small. So what is saying over here, I am going back to another example. Suppose this one. Okay. Now here it represents the height. Now see, if I give a condition that if the height is greater than 179, then it will be said as tall, right? So see the difference between the crisp set. Crisp set means the classical set or Boolean set. Now the crisp set and the fuzzy set, what is the difference? Now if it is 179, then its membership is 0. That means this height does not belong to that tall set, right? But you see, in a fuzzy domain, starting from 152 does not belong to the tall set, but starting from 155, all the heights belong to the tall set, but with a different membership degree. So as you grow up, your membership values will also be increased. Are you getting the difference? Can you distinguish these two? So basically there is a sharp boundary, as I said. So this is the picture of pictorial representation of the previous example, right? So there is a sharp boundary between the not belong to the set and belong to the set, right? So as you cross 179, suddenly it jumps up to 1 and all the elements in this region completely belong to the set in a Boolean logic. But you see that the line in a fuzzy domain, right? So what is happened over here? As you cross 152 or maybe 152, then all the elements are belong to this set, but with a different membership degree. Is it clear? Any question? Are you getting the difference? Classical logic, actually classical set or classical logic follows the Boolean logic. So classical logic and Boolean logic are same, right? Right. Now, right, continuous ka, because to me, it is not possible for a human being to differentiate between say 180 centimeter and 160 centimeter or 62 centimeter. Okay, it is not very difficult, it is not easy to distinguish. Okay, so that's why what you are doing, you keep both these elements into the set, but their membership degree will different. So with that membership degree, you can distinguish that 160 may be in the set, but with a less membership degree. So that means it is not exactly the tall set, but maybe it can be tall, like that. Okay, so that is the term I can use, that 160 centimeter may be tall, may not be tall, may be tall or may not be tall, right?
Sir,
but
স্যার বলছি গ্রেটার মেম্বারশিপ ডিগ্রি আর লেস মেম্বারশিপ ডিগ্রি এর ডিটারমাইনটা করব কিভাবে?
সেটাতে আসছি, সেটাতে পরে আসছি, ঠিক আছে? কিভাবে ডিটারমিন করবে, দ্যাট ইজ I will come to that, but you just first try to understand the difference between these. বলো। হ্যাঁ, বাট এবারে যখন তুমি ধরো একদম উপরে যখন চলে গেছো এই টেবিলটাতে, মানে সে 205 কি 208, you can definitely say that it is tall, right?
So
Because its
170
membership
যদি হয়,
degree is 170 যদি হয়, say 170, 172, so its membership degree is 0.24. Now it is up to you. Okay, মানে it is up to you that how you determine that thing. মানে এই যে ভ্যালু গুলো, মানে ফার্স্ট কোশ্চেন দ্যাট কামস টু ইউর মাইন্ড, শুড কাম টু ইউর মাইন্ড, দ্যাট how do you get this value, right? So can anyone tell me that how do you get this value? মানে এই ভ্যালু গুলো আসলো কোথা থেকে? Where from this value came?
sir 1 by height.
That মানে এই ভ্যালুটা আসছে কোথা থেকে? মানে এটা ভুলে যাও, মানে my question is যে who gives this value, this membership degree?
মানে probability কোন ব্যাপার আছে?
No, there is a function which is called as membership function, right? And that is the responsibility of the programmer to define this membership function, right? Nobody will give you. Okay, it is your responsibility. If you are a programmer, it is your responsibility to define your membership function. Now, what the membership function will do? Membership function is actually applied on an element, and that will return the corresponding membership degree. Right? So it's a kind of heuristic. Okay, মানে the heuristic that we have seen in the earlier classes, like say fitness function for genetic algorithm, evaluation function for a game playing situation, etc., etc. Like heuristics, here membership function is also a heuristic. Okay, মানে how close your inference will be, that depends on how efficient your membership function is. Okay, now let me go. So
আপনার ভয়েসটা ব্রেক করছে।
আমার ভয়েস ব্রেক করছে? Is it okay now? Is it clear now?
হ্যাঁ,
তাই কি? আচ্ছা, okay, okay, now is it clear?
yes sir.
Okay, fine. Now so a bit of history, although it is not very significant, but you still should know. Look, Professor Lukasiewicz, he is the person who introduced the fuzzy logic. But Professor Zadeh, I hope many of you have heard about this name, Professor Zadeh, who made this fuzzy logic popular, right? So you can find his paper in the internet if you are interested. Zadeh's paper is a famous paper on fuzzy set and fuzzy logic. So you can, if you are interested, you can refer to that. Now I am moving the part. So now come to the definition. So as I said, that in the crisp set also, how do you define a crisp set or classical set? It is defined like this, that there is a mapping from this universal set to two-valued system, that is 0, 1, 1. So that will be 0 if x belongs to a, and sorry, if it is 1, then it belongs to a, and if it is 0, that means the element does not belong to a, right? That is the definition for the classical set. Okay, but whenever we are moving to the fuzzy set, so now I am moving to the definition of the fuzzy set. Now see the difference. So what is the difference? Here it is called as characteristic function. Now in the fuzzy domain, it is called as the membership function. And the standard notation of using or writing the membership function is this: mu x a. Try to understand the meaning. Membership of x in the set A. Membership of x in the set of A, right? Now it's a mapping from x to the closed interval 0 and 1. Okay, now that will be 1 if it is totally in A. It is 0 if it is not in A completely. And in other cases, the value can be lies in the range from 0 to 1, in the interval 0 to 1. Are you getting the point? So that is called actually the degree of membership. or membership value. And this is called the membership function that I am talking about. That is a function. There should be a function. That function will map every element in this interval. Okay. How to do this? How to do this? Let me show you one example. Let me show you one example. I hope from this this membership function concept will be clear to you. Now, suppose a fuzzy set is defined like this: set of real numbers close to 0. Right? I need to represent this fuzzy set. Set of real numbers close to 0. Try to understand the difference. Now, can it be a, if it is a, can it be a classical set? Can it be a classical set? Why I am saying that? Why I am saying that it's a fuzzy set? Why not it's a classical set?
মানে ক্লোজ টু 0 বলতে 8 না 9 এরকম কিছু বলা যাচ্ছে, মানে ক্লোজ টু 0 সে মানে আমি 6 কেও ক্লোজ টু 0 বলতে পারি, সো দ্যাটস ওয়াই ইট ইজ called the fuzzy set.
Right. তাহলে so now, so that's why it's a fuzzy term, right? মানে whenever I am saying a term called close, it's a fuzzy term, right? So, but one point is, so for that I need to define a function. I need to define a membership function. So this is a membership function which is defined for this set, right? Mu ax equal to 1 by 1 plus x squared for all x belongs to a. Now tell me, for which value this membership value should be 1? Mane, which is absolutely close to 0. Which value is absolutely close to 0?
1.
But which is absolutely close to 0? 0 itself.
Yeah, 0 itself.
0 itself, right? So now
Yes.
you just put the value of x equal to 0 over here. So what you will get? 1. So the membership degree of x, that means 0, is 1. So that's why you see the curve. So for 0, the membership degree is 1, right? But as you go apart in the both the sides, then the membership degree will be increased, right? Are you getting my point, what I'm trying to say? So for 1, what will be the membership degree? If you put 1 over here, so 1 by 2. 1 by 2 means 0.5. So for 1, it is 0.5. Similarly, for -1 also it is 0.5. Right? Is it clear? Is this example clear? Are you getting this example? So this is actually the example by which I want to show you that how a membership function could be defined. Now that is defined by someone. It is not coming accidentally or automatically. Someone will provide you, not like that. Someone has defined this. So if you are dealing with a fuzzy set, you have to define your own membership function, right?
Yeah. স্যার যদি নাম্বার গুলো ইনক্রিজ করে তাহলে আমার মেম্বারশিপটা একটু কমে যাচ্ছে, একটু উইক হয়ে যাচ্ছে মেম্বারশিপ নেসটা, আমি বলতে পারি?
হ্যাঁ, অবভিয়াসলি কেননা তুমি তো তখন ক্লোজ টু 0 থাকছো না। বাট দ্য পয়েন্ট ইজ 1 is also close to 0, 2 is also close to 0. But how do you distinguish that? মানে how do you distinguish that 1 is much closer to 0 than 2?
Yes, sir.
Right? So that is distinguished by that membership value. মানে for 2, what will be the membership degree? What will be the membership degree for 2? Huh?
না ভুল বললাম স্যার, was there 1 by 3?
হ্যাঁ, ঠিক আছে। But for 1, so for 1 it is 0.5. So it is larger than this one, right? So what is the meaning? If it is larger than this one, means this is much closer to 0 than 2, right? Now so in this way, when the membership degree is gradually decreasing in this way, then at a time the membership value will be 0, right? So if the membership is 0, then from that onwards those elements will not belong to this set. Okay. Fine. Now, another feature I want to show you by this picture. I hope you can find the difference between these two pictures. Can anyone point it out? What is the basic feature that I want to show by this by two dots? Can anyone tell me?
Vertically uniform.
Vertically uniform. What does it mean? Acha. Common portion থাকে। তাহলে what does it mean? What does it mean? Overlapping. Very good. Yeah, that is the thing. মানে overlapping মানে এই ধরো, suppose I am giving you example over here. Say 100 না ধরো to be precise ধরো 184. Okay. Now 184 belongs to this average set also, as well as in the tall set also, right? But the difference is 184 in the average set, the membership degree is 0.1. Okay. But 184 in the tall set, the membership degree is 0.4. Okay. So what is the conclusion? The conclusion is, in the fuzzy domain, overlapping is possible. But in the classical set, suppose here, say 184, what is 184? Suppose this one, 185 or 84. It is completely in the tall set. There is no scope that this element can be in the other two sets. It is not possible at all in the classical set. But in the fuzzy domain, it is quite possible. Right? Is it okay? Pranayji bolchi? Okay, fine. So this is another difference between the fuzzy set and the classical set, right? The overlapping is possible, but here in the overlapping is not possible. Okay, now I am moving back to some extent. Now this picture is actually gives you the idea of the basic components of any fuzzy inference system. Okay, now what is that? So first one, fuzzification. Now why the fuzzification is required? Because the inputs that are given to this model is the crisp values, right? The classical values. So that needs to be fuzzified. So this module actually fuzzified. There is the inferencing system. That inference system takes the help of this fuzzified input, fuzzy rule base, and the membership function that I have already discussed. With the help of all these three, it infers something. But that inferred result is also in the fuzzy domain. But we as a user, we don't understand this. So that's why another module is required that will defuzzify it to get the defuzzified output of the corresponding input, right? So this is the whole process of the fuzzy inference. So first is a fuzzification is done, then some inference takes place. It infers something. That inferred is defuzzified to get back the crisp values, the classical values. Okay, so these are the modules that is required. Okay, now I am moving forward. What I need to show you that all the crisp set operations, classical set operations, can be defined in the fuzzy domain, right? Like say set union, set intersection, complement, etc., etc. All these can be defined, right? So I am coming to that, but what my system shows that it is less than 1 minute time left. So I am stopping over here, and you please join immediately. না তো তোমাকেই করতে হবে, মানে তুমি যদি প্রোগ্রামার হও তাহলে তোমাকেই করতে হবে। মানে হোয়াট আই এম ট্রাইং টু সে, এই যে ধরো এই এক্সাম্পলটা, there are three sets, okay, short, average, tall, short, average, tall. এবারে এই তিনটেই কিন্তু সেট, these are the three different sets. So there
Yes.
will be a membership function for short, there will be a member function for average, there will be a member function for tall.
Yes, sir.
Right? Okay. Fine. Okay, so up to this, anyone having any queries, any question, you can ask me. So I am moving to definition of the set operations in the fuzzy domain. So first one is the complement. Now complement of a set, in a fuzzy domain, the complement is defined like this, right? So membership of x in complement of A, that will be 1 minus membership of x in A. Okay, I will show you the example, then it will be clear much more. But let me give you the definition first. So this is the definition of the complement. Okay, next is intersection. Now what is intersection? Intersection is membership of x in A intersection B, that will be the minimum of the two memberships, right? The membership of x in A and membership of x in B, that is called the intersection. The union is the or means is the maximum. Okay, now equality, when you are saying that two sets are equal, suppose this A and B are equal, when the membership degree of all the elements in A and B are same, 0.3, 0.51, 0.3, 0.51. Okay, now another thing I maybe missed, that is, this is the way to write a fuzzy set, right? This is the standard notation. What is the notation? First is the membership degree and followed by the element. Here this slash is not the division, mind it. This is not the division. This is the slash that is distinguished between the membership degree and the element. Membership degree and the element. Membership degree and the element. Okay, so if this happens, then you can say that two sets are equal. Now similarly, subset. Wherever you are saying that A is a subset of B, if the membership of x in A is less than equal to membership of x in B for all the x belongs to capital X. So suppose this. So here A and B, 0.3, 0.51, 0.5, 0.551. So for all the elements, this principle is followed. So that's why A is a subset of B. Are you getting the point?
মানে স্যার এটা বিটা
Similarly, the cardinal.
মানে স্যার বিটা
হ্যাঁ, বলো।
কি এর থেকে
হ্যাঁ, মানে না, বিটা এর থেকে বড় না, সেটা বলার থেকে the thing is the membership of x in B is greater than equal to the membership of x in A for all the elements.
Yes, sir.
Right? Acha, next হচ্ছে cardinality. Cardinality in the classical set, what is the meaning of cardinality? Is the number of elements present, right? But here the cardinality is the summation of the membership degrees. So what is the cardinality of A? 0.3 plus 0.5 plus 1, 1.8. Cardinality of B, 0.3 plus 0.55 plus 1, that is 2.05. So that is called the cardinality of a fuzzy set. Okay. Now empty set, if empty set will be empty if all the values, for all the elements the membership degrees are 0, then it is called the empty set. Okay, now I am use some example, then it will be much more clear. Because this is your A set, this is your B set. Okay, so now then what will be the complement? How do you find out the complement? Suppose A is this, then not of A will be what? Not of A will be 1 minus membership of x in A, right? So 1 minus 1, 0, 1 minus 0.3, 0.7, 1 minus 0.2, 0.8, 1 minus 0.8, 0.2, 1 minus 0. Okay, so that is the way how you find out the complement. Now union, what I am saying, union means the maximum. Okay, so suppose this is your A and B. Okay, so what will be the union? Can anyone tell me? Just try it to find out the union of A and B. What will be the result?
The summation of A plus summation of and summation
No.
of
No. Union means what? Union means, the definition says, the maximum of the two membership degrees. তাহলে কি হবে? In capital A, the membership of small a is 1 and membership of small a in 0.6 in B. So what will be the membership in the union set? A is there and B is there. So what will be the union? How do you calculate the union? How do you form the union? Yeah. So Vedika says 1 way. Fine. So basically, the definition says that the maximum of the membership degrees. So here the membership of A is 1 and here membership of A is 0.6. So 0.6 and 1 is the maximum. So the membership in the union set of A will be 1. Then for B it will be 0.9. For C it will be 0.2. For D it will be 0.8. And for E it will be 0.2. Okay. So that is the union. Similarly, for intersection, it will be the minimum. Okay, it will be the minimum. So the same way, the minimum you can find. Next is cardinality. What is the cardinality of A? How can you form the cardinality? Cardinality is, as I said, the summation of the membership degrees. So 1 plus 0.3 plus 0.2 plus 0.8 plus 0. So that will be the cardinality of A, that is 2.3. Similarly, the cardinality of B will be like the same. Okay. So this is the way how you can calculate or you can find all the what I can say, all the said operations. Okay. So with this introductory things, the basic things, now I am moving to the fuzzy inference. Now for fuzzy inference, the first one that I need to find out is the fuzzy relation. Now before going to the fuzzy relation, I want to know from you, can anyone tell me what is the mathematical definition of a relation? Can anyone tell me? How can you define a relation? Relation, how do you form a relation? Yeah, someone write something. Subset of A cross A. Yeah, subset of A cross A, not A cross A. If it is a relation between two sets A and B, then it will be the so as far as your definition is concerned, is subset of A cross B, right? Yeah, fine. So now, so that is the thing. Very good. So what I am trying to say, so a crisp relation, a classical relation, the basic definition is that first you need to find out the Cartesian product of two sets. How do you form the Cartesian product? You know. Okay, I don't need to repeat all these things. Cartesian product is basically the ordered pairs. Okay, so ordered pairs like AB, where A comes from A and B comes from B. Okay, so that is the Cartesian product. And what is the relation? Now, relation is nothing but a subset of this Cartesian product. Okay, if it is a binary relation, then there will be two sets. If there is a ternary relation, there will be three sets. If it is an n-ary relation, then there will be n such sets. Okay, so first you need to find out the Cartesian product, and then you take the relation, then you take the subset. Okay, that is called the relation. Okay, that is a basic definition, the mathematical definition, right? Now, here in a fuzzy domain also, we need to find out the fuzzy relation. So how do you find out a fuzzy relation? Can anyone guess, or taking a guess to tell me that how can a fuzzy relation can be defined? Because there will be a fuzzy sets. Instead of a classical set, there will be two fuzzy sets. So I want to find out, I want to create a fuzzy relation. How do I create a fuzzy relation? Any idea from anyone? Okay, so let me give you one example. Suppose the example, you see this example, although it is the definition is written over here, I'm coming to that definition, but before that, I want to show you the example. So suppose R is a fuzzy set that is defined like this, and S is also a fuzzy set that is defined like this, right? Now I want to create a relation, fuzzy relation between R and S. So here also I need to create a cross product of R and S. So if I take the cross product, so here R is there and S is there here. Row wise the elements of R is placed, and column wise the element S is placed, right? So basically Cartesian product means what? You know, Cartesian product means it's an ordered pair. So here also the ordered pair is there, say A1, A2, A3, B1, B2, B3, C1, C2, C3. But since here with all elements the membership degree is associated, so the definition it says that it will be the minimum of the membership values. Okay, so let's see what happens. So A1 in this entry, what will be the value? Now see, for A the membership degree is 1, for 1 the membership degree is 1, so between 1 and 1 the minimum is 1. Then A2, so A the membership degree is 1, and for 2 the membership degree is 0.5, so between 1 and 0.5 it is 0.5. Similarly A and 3, A is 1 and 3 is 0.8, so it will be minimum of 1 and 0.8, so here it will be 0.8. Okay, there is an error. Okay, instead of 0.9 here it will be 0.8. Similarly B1 it is 0.81, so it is 0.8. B2 it is 0.5, and B3 it is 0.8. Right? Are you getting it? Are you getting how to form the fuzzy relation?
Sir,
শোনা যাচ্ছে না প্রণয়।
হ্যালো স্যার, যখন আমি B3 করছি তাহলে আমাকে দেখতে হবে B1 2 3 এর মধ্যে কোনটা মিনিমাম।
না, বি এর মেম্বারশিপ ডিগ্রি বলা আছে তো 0.8, আর 3 এর মেম্বারশিপ বলা আছে 0.8, so you take the minimum of 0.8 and 0.8 and that is 0.8, so that's why it is 0.8 over here.
ওকে স্যার,
এবারে B1 ধরো B1 যখন করবে, এবারে দেখো B হচ্ছে 0.8 আর 1 এর হচ্ছে 1, so minimum of 0.8 and 1 that is 0.8. ঠিক আছে?
yes sir, yes.
Okay, so that is the way how you create a fuzzy relation. Okay, now come to the inference. So suppose inference is what here in terms of fuzzy domain, the inference is basically, suppose there is a relation R which is the relation between A and B, and S is the relation which is the relation between B and C. Now I want to find out, or I want to infer a relation between A and C. That is the inference over here. Mane the relation between A and B is given, the relation between B and C is given. Now you want to infer the relation between A and C. Okay, that is the inference over here, and for that we have two operators. One is called the max mean composition. Another one is called the max product composition. Okay. So let me tell you first what is max mean composition. Again, I am showing you an example that will be much more clear to understand. So suppose R is the relation between X and Y. S is a relation between Y and Z. Now I want to infer a relation between X and Z. Okay. So how to form a relation between X and Z? So let's see what happens. So basically it's a max mean composition, means it's a max of mean. So first you calculate the mean and then you take the max of that. So how do you create? So first you take this way, that x1 y and y z1, right? Then you can get the value in the entry x1 z1. Okay, so what is happened over there? You see, first you try to find out the minimum of 0.7, 0.9 and 0.5, 0.1. So 0.7, 0.9 the minimum is 0.7, 0.5 and 0.1 the minimum is 0.1, right? So now take the maximum of 0.7 and 0.1, that is 0.7. So basically it's a max of mean, right? That's why it is called max mean composition. Okay, max of mean. Are you getting the point? First you try to find out the minimum and then you take the maximum of that. So you are going in this way. So x, you are trying to find out the value in the entry x1 z1. So what you are doing, x1 y, you find out x1 y. So x1 y means x1, so this row, and then y z1. So y z1 means basically this column, right? So this one, right? So 0.7, 0.9, 0.5, 0.1, take the minimum of that and then take the maximum of that. Similarly, x1 z2. How to calculate x1 z2? So x1 y, right? x1 y, that means take the minimum of 0.7, 0.6, that is 0.6. Take the minimum of 0.5, 0.7, that is 0.5. Now between 0.5 and 0.6, take the maximum, that is 0.6. So 0.6 is coming.
Sir,
বলো।
স্যার বলছি এই যে এটা মিনিমামটা বলেছি, তখন ম্যাক্সিমামটা একটু ভুলে যাচ্ছে, একবার একটু এক্সপ্লেন করুন স্যার।
হ্যাঁ, ওই তো বলছি, দেখো ভালো করে বোঝো। মানে যেরকম ভাবে ম্যাট্রিক্স মাল্টিপ্লিকেশন করো, দিস ইজ দ্য সেম আইডিয়া। মানে ইউ টেক দিস রো উইথ দিস কলাম, ঠিক আছে? আবার দিস রো উইথ দিস কলাম। তাহলে ফার্স্টে দেখো এই রো আর এই কলাম কি হচ্ছে, x1 y1, x1 y1 আছে 0.7, টেক দ্য মিনিমাম অফ 0.7 and 0.9। তাহলে মিনিমাম অফ 0.7, 0.9 মানে হচ্ছে 0.7, আর টেক দ্য মিনিমাম অফ 0.5, 0.1, তার মিনিমাম হচ্ছে 0.1। ওকে, ফার্স্টে এটার মিনিমাম, এটার মিনিমাম, তাহলে এটার মিনিমাম হচ্ছে 0.7, এটার মিনিমাম হচ্ছে 0.1। এবারে এই দুটোর মধ্যে ম্যাক্সিমাম, তাহলে 0.7 আর 0.1 এর মধ্যে ম্যাক্সিমাম, দ্যাট ইজ 0.7। ঠিক আছে? এবারে পরেরটা করো, ধরো x1 আর z2, তাহলে 0.7, 0.6
আর y1 স্যার 0.6 টা হচ্ছে এখান থেকে।
হ্যাঁ, তাহলে 0.7, 0.6 এর মধ্যে মিনিমাম হচ্ছে 0.6, আর 0.5 আর 0.7 এর মধ্যে মিনিমাম হচ্ছে 0.5। এবারে 0.5 আর 0.6 এর মধ্যে ম্যাক্সিমাম হচ্ছে 0.6, সো 0.6।
Yes sir, I understood sir.
Okay, so that is the way how max mean composition is done. So max mean composition, what is the significance, why it is used? It is used to infer a new thing. Okay, the new thing means what? Here the relation is given between x and y, relation is given between y and z. You try to find out the relation between x and z, that is the infer. So in the same way, হ্যাঁ বলো
স্যার বলছি কোশ্চেনে এই টাইপেরই আসতে পারে যে মানে
হ্যাঁ এই টাইপেরই আমি বলছি। আরো একটা দুটো এক্সাম্পল আমি দিচ্ছি। So similarly there is a max product composition. Difference is that in a max product composition, instead of taking the minimum in between, here you do find out the product and then take the maximum. Okay, that is the difference. So everything is same. Now come to another example. So this is another example of inferencing. This is a if then else rule. Okay, because in a classical set we are very frequently facing this if rule, the rule, but here in a fuzzy domain the rule will be changed a bit, right? How? Now suppose it is like this. So there is a rule format. It's a example of a rule in a fuzzy domain. So if X is young, then X is a fast runner. What does it mean? Basically, it's trying to find out a relation between young and fast runner. Young is a set, fast runner is also a set, right? Suppose this, it is given a example over here. It's a young. Young means basically elements at the age. Okay, 10, 20, 30, 40. And it's saying that the 30 has the maximum degree. Why it is so? Because it's saying that the age of 30 is the most young. Okay, and fast runner is basically the speed. Okay, so basically it tries to find out the relation between young and fast runner. But as the age grows, how your speed grows, that is the thing. Okay, so how to find out relation between young and fast runner? So it's nothing but the same way that we have seen that in the horizontally the ages are there and vertically the speeds are there. 10, 20, 30, 40, 5, 8, 10, 12. How you get these values is basically the minimum value. Like the way I define the relation over here. Like the way I have defined the relation over here is the same way this relation has been built. Okay. Now the question is, suppose a new set is given. Okay. New young set means the different membership function values are there. Okay. So for that, what could be the first runner set that can be inferred? Okay, that question. So you have to, what you have to do, you have a relation, so you have a relation between age and speed. Now you apply the max mean composition or max product composition, whatever you are comfortable. You apply this max mean composition with that relation and with this vector. Now see what is happened here. Your matrix is what is 4 cross 4, right? It's a 4 cross 4 matrix, and this vector is a 1 cross 4 vector, right? So to make this thing suitable, what you need to do, you need to make this row vector as a column vector. So if you find a column vector, then the dimension becomes 4 cross 1, right? So if you apply the max mean composition over here, but if there is a 4 cross 1 vector and it's a 4 cross 1 matrix, 4 cross 4 matrix, then your resultant will be a 4 cross 1 vector, right? So it's a 4 cross 1 vector like this. Okay, so if you apply max mean composition with this relation and with this vector, you will ultimately find out a vector like this. The same way I have given you an example. The same thing you need to do for this matrix along with this vector. Okay, so you apply the max mean composition. If it is difficult for you to do right now, you can take this. You can take a snap of this. Multiplication? Multiplication sign? No, it's a max. It's not a multiplication sign. It's a max mean composition sign.
No, এটা না স্যার। স্যার next page যান। স্যার আবার next page যান please। পরের পেজে।
এই তো next page কোথায়? Multiplication কোথায়?
না স্যার, মানে পরের পেজে মানে যেখানে, হ্যাঁ স্যার এখানে 0.1 into 0.1 এটা বলছিলাম।
কোথায় 0.1 কোথায়?
স্যার
এটা
না এর জাস্ট পরে
এটা বলছো।
হ্যাঁ,
এটা মাল্টিপ্লিকেশন নয়, এটা বেসিক্যালি এটা বোঝাতে চেয়েছে যে ওই যে টু টেক দ্য মিনিমাম অফ দ্যাট। ওকে, মানে এই যে কাজটা এখানে করেছিলাম, দ্য সেম থিং, এই যে the minimum of that. Okay, so the same thing is happened over here.
Okay sir,
multiplication. Yeah. Okay, so So this is the way how the fuzzy inference. So everything you have deal with in terms of the fuzzy domain. Okay, I just want to show you another couple of things that will be. Now see, this is the how you have to write the fuzzy rules over here, right? If I show you the difference, suppose this one, this type of rules we are very much frequently used in our classical domain, right? That if speed is greater than 100, then stopping distance is long, or the stopping distance is short, right? So here there is a fixed value, right? Is greater than 100 is a fixed value. But whenever we are coming to the fuzzy domain, the way to write the rule is like this. If speed is fast, not greater than 100, not any specific value. If speed is fast, then stopping distance is long. So here the fast is a fuzzy set. Okay, so there will be a speed value. You put that speed value in the membership function of the fast and take the membership degree, right? Similarly, if speed is slow, so slow is another fuzzy set. Okay, there will be a membership function for fast, there will be a membership function for slow also. Okay, so that is the difference. That is the difference between the classical rule and the fuzzy rule. Okay, like this. If height is tall, then weight is heavy. So here tall and heavy both are fuzzy sets. If height is tall, then weight is heavy. Okay, so similarly here all there are some conjunctions or disjunctions in the conditional part or conclusion part. If project funding is long and project staffing is large and project finding is inadequate, then risk is high. So everything is a fuzzy set. Long is a fuzzy set, large is a fuzzy set, inadequate is a fuzzy set. Similarly, high is also a fuzzy set. Okay, so this is the way how you should write the fuzzy rules in the fuzzy domain. Clear? Okay, so that is the thing. That is the thing that I want to discuss about this fuzzy logic, because as again I am saying that in this course I don't have any scope to discuss much about these topics, because here I am given a very one period lecture to cover all these topics, right? So that's why it's a brief introduction, so that you get an idea, right, how the fuzzy logic works, fuzzy set works. Okay, fine. Now if anyone having any queries other than this, you can tell me, because I have a 10-minute of time. So if anyone having any question regarding the lab assignments also, you can tell me, and if not, then I will stop over here.
Sir, lab syllabus is completed.
ল্যাব সিলেবাস কমপ্লিট কোথায় হলো? প্রোগ্রাম করলে কোথায়? প্রোগ্রাম তো করলেই না। ল্যাব হবে আগে থিওরিটা কমপ্লিট করে নিই, দেন ল্যাব করাবো। ঠিক আছে, দেখা যাক কিভাবে করানো যায়। অ্যাসাইনমেন্ট গুলো যেগুলো দেওয়া হয়েছে সেগুলোকে কমপ্লিট করো আস্তে আস্তে। ঠিক আছে, আরো অ্যাসাইনমেন্ট আসবে।
স্যার ওগুলো কি .pl এর মানে করে কি আপনাকে দিতে হবে, না মানে এমনি পেপারে লিখে ছবি তুলে?
সেগুলো বলবো, দেখি আগে কি হয়। তোমরা করে তো রাখো আগে।
ঠিক আছে,
যেগুলো পারছো সেগুলো করো। ইফ কোনো প্রবলেম, কোনো প্রোগ্রাম যদি বুঝতে অসুবিধা হয়, you can mail me. Okay, if you are having any difficulty in understanding any program, any problem, you can let me know. Okay. Okay, so I assume that there is no such queries.